Hello my dear students of grade 11. Today I am going to discuss with you all Unit 8 of your science textbook. That is a chemistry lesson and the topic is heat changes associated with chemical reactions. So you are already familiar with physical changes and chemical changes. And you all know in chemical changes or chemical reactions, the reactants are converted to products. And also you are familiar with the observation of this change, how we see the reactants changing to products. In addition to that, when we discussed the previous lesson, acids, bases and salts, what did we say? When acids are diluted or when acids dissolve in water or bases dissolve in water, we said they evolve heat. So we have to be careful. And also when we did activities, you can remember I told you when we dissolve say sodium hydroxide in water, I said the beaker becomes hot. So that means when there are changes, that is mainly chemical changes taking place, there is a change in heat. So that is what we are going to discuss under this lesson. So under this also we are going to discuss all the changes that come under heat changes associated with chemical reactions. Under that we will be mainly looking at two main types of reactions. One is known as the exothermic reaction. Exothermic reactions. So here exo means out. Thermic means related to thermal energy. So that is heat energy. Reactions that are accompanied by the loss of heat or releasing of heat. And then we have endothermic reactions. Endothermic reactions. So here again endo means in. So thermic heat energy. Heat energy is absorbed during a chemical reaction or chemical reactions that are accompanied by the absorption of heat. So those are the two main types of reactions, and also we will see how we can determine the heat change of a chemical reaction as well as how these types of reactions are encountered in our day-to-day activities. So to understand that, we will move on to the lesson. So again, here this is something that you have learned in grade 10. Recall again about the evidences you have learned in grade 10 to ensure that a reaction has taken place. So evidences. In order to understand the evidence, I will give you all an example. So let's say we'll take the reaction between calcium carbonate solid and hydrochloric acid solution. You all know the products. Those two are the reactants, and what are the products? You can remember calcium chloride aqueous is formed, water and carbon dioxide gas. Now, when you look at this reaction, you take a small amount of calcium carbonate or even marble chips can be used. So, that is solid white color powder and hydrochloric acid is a colorless solution. And when you mix them together, what do you see? You can see dissolving of calcium carbonate. And also you can see evolving of carbon dioxide gas. So in this, you can see the disappearance of calcium carbonate or dissolving of calcium carbonate and the evolving of carbon dioxide gas. So from those two observations, you know that the reaction is taking place. In addition to this, you have studied many other reactions. Consider the reaction between magnesium strip and again hydrochloric acid solution, dilute hydrochloric acid. You know the products magnesium chloride and again evolving of hydrogen gas. Now in this also you can see dissolving of magnesium the magnesium strip dissolves and finally disappears, and also evolving of gas bubbles. But in both these reactions, what do you feel? If you touch the beaker, you can still feel it becoming slightly warm, especially this particular reaction. So here you see that beaker becomes warm. That is something that you observe there. Another type of observation, if you can remember, students. Let's say the reaction between copper sulfate and zinc. That is something familiar to you all. Copper sulfate solution and zinc solid. What are the products? It will be the formation of zinc sulfate and copper solid. So, in this reaction, what do you see? Initially, you know this is a blue color solution, but with time, you can see the decrease in color. And you can see the zinc plate dissolving and also precipitate forming. What will be the color? Reddish brown. That is the copper precipitate. So you can see the blue color of copper sulfate decreasing, zinc plate dissolving, and also the copper metal precipitating as a reddish brown color precipitate. In addition to that, here also you can feel the beaker becomes warm. So all these are activities that you have seen, and you have seen these observations, so you are familiar with those. So normally we see the dissolving of reactants or disappearance of the reactants, evolving of gas bubbles, color change, formation of precipitate. So all these are evidences that a chemical reaction is taking place. In addition to that, now in these two reactions and many other reactions, you would have heard or you would have felt the beaker becoming warm. So that means there is a heat change associated with those reactions. That is what we are going to concentrate on in this lesson. With that, I will move on to the next slide where we discuss this first activity. Activity, understand the temperature changes taking place during a chemical reaction. So here we are always concentrating on a chemical reaction, not a physical change. And for that we need these materials. We need beakers actually. And here we need a thermometer. A glass rod, and we need sodium hydroxide, that is NaOH, and we need ammonium chloride, that is NH4Cl. So these are the materials that we need. We need beakers, thermometer, glass rod, sodium hydroxide and ammonium chloride solid. And this is a simple activity. I'll go through the method. So what we will need is we need 200 centimeter cube beakers, small beakers, and into those beakers we need to take half volume of water. So fill half of a beaker with water and record its temperature. So initially we need to record the temperature. Let's say if we take this temperature as T1. The first beaker, the water that is taken in, it is T1. Then add a little amount of solid sodium hydroxide to the same beaker. Stir with the glass rod and again measure and record the temperature. So that is going to be temperature 2. Let's say T2. So here students, you have to be careful. We need to stir the solution well using the glass rod, and when we measure the temperature, we need to make sure that the thermometer is inside the solution, so we get the correct reading. And while we are stirring, one thing, we help the sodium hydroxide to dissolve, and also we help the heat to distribute evenly. So always, for activities related to heat changes, we need to have a glass rod in order to stir the solution completely. Then we need to state the observations. You have to say whether there is a temperature change or not, and if there is a change, how it changes, whether it increases or decreases. The same way, we do the activity with ammonium chloride. Fill half of a beaker with water and record its temperature. We can, let's say, take it as T3. Add a little amount of solid ammonium chloride to this beaker. Stir with the glass rod and record the temperature again. So that will be T4. And again state your observations. So this is a very simple activity. We need 2 beakers, 2 different solids. We dissolve them and observe the temperature change by recording the initial and final temperature. And always, when we calculate the change, we subtract the final temperature from the initial temperature. That is important. So here always temperature change is going to be final temperature minus initial temperature. Here, instead of temperature, I have written it as TEMP. So, always final minus initial temperature. That's the change that we are going to observe. So, now that you know the procedure of the activity, it's a very simple one. Let's go to the lab and do this activity. So, now we are going to do this activity to understand how heat changes take place during a chemical reaction. So, to understand that, I have 2 chemical substances. One is sodium hydroxide. You all know it's a base. And here I have ammonium chloride. That's a salt. So, first what we have to do is we need to take 2 beakers, 100 centimeter cube beakers. Into that, to about half the volume of the beaker, we need to take distilled water. So, into both the beakers, I'll take equal volumes of water. We don't need to measure the volumes. It's just that they need to be equal volumes. So now that I have the 2 beakers with water, then I have the thermometer and the glass rod. You all know the purposes. Glass rod is used to mix the solution well, and the thermometer to get the temperature reading. So to this, I will add initially, before I add the substance, we will take the reading of the thermometer. So here you can see the temperature reading. It's 25 degrees. So that's the temperature of water. So after that, I will be adding the sodium hydroxide. I'll add sodium hydroxide there and mix it well. If you feel the beaker also, you can feel the change in temperature slightly. So when I feel the beaker also, it feels a bit warm. But to get a proper understanding, we need to take the temperature reading. So here you can see it dissolves well. So now if we take the reading. You can see the thermometer reading increasing. Can you all observe it? It will go up and come to a final value. So here you can see, students, the thermometer reading has come to 35 degrees Celsius. So initially it was 25 degrees Celsius. Now after dissolving only a small amount of sodium hydroxide. Still there is sodium hydroxide remaining there. So if I dissolve further more sodium hydroxide, you can see the temperature rising. So here at the moment you can see the temperature has risen to 35 degrees Celsius. So in this particular chemical reaction or chemical change, dissolving of sodium hydroxide in water, the temperature increases. That means heat is evolved. So then we will be using the next chemical substance, that is ammonium chloride, that I have here. Again for this, we will take the initial temperature reading. Here you can see 25 degrees Celsius, the initial reading of the distilled water. So again, I am going to dissolve ammonium chloride there. Even when I put the ammonium chloride in from the beaker, students, you all can observe. Normally when something becomes cool, you can see the change in the glass. You can feel it also. You can feel the beaker becoming cooler. So after dissolving it, if we take the thermometer reading, you can see the temperature dropping. So can you all see, students, the temperature has dropped down to or decreased to 21 degrees Celsius. Earlier it was 25 degrees Celsius. Now it has become 21 degrees Celsius. So the temperature has decreased. Is it clear to you all now? So in one chemical change, that is sodium hydroxide dissolving in water, the temperature increased. Whereas in the second one, ammonium chloride dissolving in water, the temperature decreased. So a chemical change is accompanied by a change in temperature, either increase in temperature or decrease in temperature. After this, we will see how we can classify these two reactions. Okay, students. So you were able to observe what happened when we try to dissolve sodium hydroxide in water and ammonium chloride in water. So what happened when sodium hydroxide dissolved in water? Initially the temperature of water was 25 degrees, and once it dissolved, the temperature became 35 degrees Celsius. So you can remember the T1 of water, 25 degrees Celsius, and T2 after sodium hydroxide dissolved. So there the temperature was 35 degrees Celsius. So what did you all observe? You observed an increase in temperature. So that means increase in temperature. Then what happened when we dissolved ammonium chloride in water? There again we had the T3 of water, that was also 25 degrees Celsius, and T4 after ammonium chloride dissolved. That was 21 degrees Celsius. So what happened there? There the temperature decreased. This is what is very important to us. And also I told you all, if we need to calculate the temperature change, if we are doing calculations, always we have to subtract the final temperature from the initial temperature. So in the first case, we will subtract 25 from 35. So you will see a 10 degrees increase, 10 degrees Celsius increase in temperature. Whereas in this one, the final temperature is 21 degrees Celsius. Initial temperature was 25 degrees Celsius. So 21 minus 25, that means there is a decrease by 4 degrees Celsius. That is if we need those values for calculation. But here we are trying to understand that there is a temperature change when chemical reactions take place. So from these two observations, students, what can you all conclude? We can conclude and say that during a chemical reaction, that is sodium hydroxide dissolving in water, ammonium chloride dissolving in water. So these are chemical changes. During chemical changes, either temperature increases or temperature decreases. Why does this happen? You all know temperature is a measure of heat. So because heat is either absorbed or heat is released during the chemical reaction, there is a change in temperature. So that is what we have to write as conclusion. So conclusion, you can say chemical changes take place with change in temperature, either increase or decrease. So why does this happen? Because heat is released or absorbed during a reaction. So is that clear to you all, students? So in a chemical reaction, there can be either increase in temperature, increase because heat is released during the chemical reaction, or there can be a decrease in temperature, that is because heat is absorbed during the reaction. So either way, a chemical reaction will take place with a change in temperature. So with that, we will try to understand these changes. So what is the reason for the increase in temperature when solid sodium hydroxide dissolves in water? I told you all, temperature is the measure of heat. So here, first look at this last sentence. The temperature change can be considered as a measure of the amount of heat either evolved or absorbed. So that is important. Temperature is a measure of heat. So in the first one, when NaOH dissolves in water, there was increase in temperature. That means heat was evolved. So increase in temperature was due to heat loss during the dissolving of NaOH solid. So if we try to represent this, we had the sodium hydroxide solid, then we had water, then we got the sodium hydroxide solution. In addition to that, heat was evolved. That is important. That is why the temperature increased. But in the other reaction, why did the temperature decrease when solid ammonium chloride dissolved in water? So I think you can guess the answer. What is it? Heat was absorbed during this reaction. Decrease in temperature was due to heat absorption during dissolving of ammonium chloride solid. So if we represent that, now ammonium chloride solid is there and water was there. These two absorbed heat when becoming ammonium chloride solution. When it dissolved, it absorbed heat. So there are two types of reactions. A reaction that evolves heat, it is known as exothermic reaction. Earlier also I told you all exo means out, given out. So heat is released. So that is exothermic. And here heat is absorbed. So it's taken in endothermic. So from this you can understand the two types of reactions, exothermic reactions and endothermic reactions. With that, I will move on to the next slide. Again, we look at an activity. Explore further about the heat changes occurring in a chemical reaction. This is to understand the first type of chemical reaction associated with heat change, that is exothermic reaction. For that activity, we need again a beaker. You can also use a boiling tube or a test tube, that is fine. We need magnesium strip, dilute hydrochloric acid, and we need a thermometer. So this is what we are going to do. Add about 10 centimeter cube of dilute hydrochloric acid to a small beaker and measure its temperature. Again here we are going to measure the temperature, let's say T1. Then add a piece of magnesium ribbon about 2 centimeter long into it. Measure the temperature at the end of the reaction again. So here we are going to measure the second temperature. So I'll just label it as T2. And you need to record your observation and see whether there is an increase in temperature or decrease in temperature. So a very simple activity. You have seen the magnesium reacting with hydrochloric acid before also. But here we need to concentrate on the temperature change. So let's go to the lab and do the activity. So now we are going to observe how the heat change takes place with the reaction of magnesium strip with dilute hydrochloric acid. So here I have the clean magnesium strips here and also small pieces of magnesium strip as well as the dilute hydrochloric acid solution. From this I am going to take about 10 milliliters of hydrochloric acid into this other small beaker. So again here we are not doing a quantitative measurement. So approximately I have taken 10 centimeter cubes of HCl. So after that we have to measure the temperature, initial temperature of the hydrochloric acid solution. So can you all see the initial temperature, students? It's 27 degrees Celsius. So then I'm going to add the magnesium strips into it. small pieces because they can react better. So here, as I put the magnesium strip, you can see the evolving of hydrogen gas. You know the reaction between magnesium and hydrochloric acid. While it is reacting, you can see the evolving of hydrogen gas, but you have to observe the change in temperature. So you have to look at the thermometer clearly. Can you all see the temperature rising? Now it is closer to 30 degrees. So you can see, students, it has risen up to 30 degrees Celsius, but still the magnesium strip is reacting. Now it has come up to about 32 degrees Celsius. So initially the temperature was 27 degrees Celsius. Now the temperature has become 32 degrees Celsius. So in this reaction also, the reaction between hydrochloric acid and the magnesium strip, you saw that the temperature increases. We will be discussing these types of reactions and they are known as exothermic reaction because the temperature increases due to the release of heat from the reactants. So did you all observe how the heat change took place when we did the activity? When magnesium reacted with hydrochloric acid, you were able to see the evolving of hydrogen gas, that I am sure. And in addition to that, we were concentrating on the change in temperature. So what was the initial temperature of hydrochloric acid? It was 25 degrees Celsius. And what was the final temperature after magnesium reacted with hydrochloric acid? It was 33 degrees Celsius. So that was our observation. So here we have temperature of hydrochloric acid of HCl, that is the initial temperature. That was 25 degrees Celsius. Then temperature after the reaction of magnesium with HCl, that was 32 degrees Celsius. Is that okay, students? So what happened here? There was an increase in temperature. That is the important one. So there was an increase in temperature. So from this observation, you can see there was an increase of 7 degrees Celsius. The final temperature is 32 degrees Celsius. Initial temperature is 25. So the difference is 7 degrees Celsius. But for us, the important thing is there was an increase in temperature. So from this, what can we conclude? This particular reaction between magnesium and hydrochloric acid occurs with increase in temperature. Why? Because both magnesium and hydrochloric acid together, they release or evolve heat when reacting. That is what we can conclude from this activity. And what do we call those types of reactions? Those are known as exothermic reactions. So here we can say temperature increases during the reaction of magnesium with hydrochloric acid because heat is evolved. These are all different terms, or you can say released, or you can even say liberated during the reaction. And then, how do we call these reactions? These are known as, these reactions are known as exothermic reactions. Exo means out, that is heat is released or heat is liberated to the environment or the surrounding of the reactants. So that is an exothermic reaction. Is that clear to you all students? So here we saw that there was an increase in temperature, and that means the reaction took place with increase in temperature because there was heat evolved during the reaction. And we call these reactions as exothermic reactions. So with that, we will try to understand what these exothermic reactions are. So exothermic reactions. What we saw before, magnesium reacting with hydrochloric acid is an exothermic reaction. Why? Because the reactants evolve or liberate heat, and that is why the solution as well as the beaker became hot. That is what we observed during the activity. So the chemical reactions happening with the evolution of heat are called exothermic reactions. Evolution of heat, liberation of heat, releasing of heat, everything mean the same thing. So exothermic reactions can be represented simply as follows. First, we will take the example that we have discussed. Magnesium solid with hydrochloric acid aqueous. When the products are formed, that is magnesium chloride aqueous evolving H2 gas. Now with this, in addition to these two products, there is evolving of heat. Now this is why we call this an exothermic reaction. Exo means given out. Let's take the reaction mixture. So here inside the beaker, we have magnesium plus HCl. So what happens is these two reactants, when they react together, they release heat or evolve heat. Now from this, heat is released, or we can say evolved. So in this reaction, if we look at the overall change, magnesium and hydrochloric acid are the reactants. They have more heat energy. When they are being converted to magnesium chloride and hydrogen gas, they have less heat energy. Why? The heat is being released. So that is what happens in an exothermic reaction. Reactants evolve heat when forming the products. So this heat that is released or liberated by the reactants are given to the mixture, the solution as well as the container. So that is why when we use the thermometer, we can see the temperature increasing, the temperature of the solution increasing, as well as if you fill the beaker, you will feel it becoming hot. So both the solution as well as the container take up this energy. So reactants evolve heat when forming the product. The heat released is given to the solution and the container. Therefore, the temperature of the solution and beaker increases. So that is what happens in an exothermic reaction. If we denote this as a common reaction, we have the reactants and the reactants are forming products. While they form products, they evolve heat. So according to this, if you look at the amount of heat present in the reactant and the product, so heat energy of reactants is greater than that of products. Is that okay, students? So because reactants have more energy, products have less energy, the excess energy is evolved or released as heat energy, and that leads to the change in temperature. So those reactions are the exothermic reactions. If we consider some examples, now there are two examples that we have already discussed. Examples. The first one, we looked at the reaction of magnesium with HCl. This is a metal reacting with acid. Usually they evolve heat or release heat. Another example, we saw the dissolving of sodium hydroxide solid in water, forming the sodium hydroxide solution. So here also bases dissolving in water, that also releases heat. Another example that also you all know, students. Remember the dilution of acids. When you have the concentrated acids, concentrated acid, by mixing with water, we dilute it and get the dilute acid. This also evolves heat. That is why we say not to pour water into acid. Instead, drop by drop we add acid into water when we need to dilute it, because it is an exothermic reaction. Then another example you all know, sodium reacting with water. This is also another example. I am giving you all some examples so that you can remember. You will be able to identify the exothermic reaction. Sodium reacting with water, giving sodium hydroxide and evolving hydrogen gas. You are familiar with that reaction as well. Then another common example is the acid-base reaction. Acid-base neutralization. This is also an exothermic reaction. Acid-base neutralization reaction. Another one, production of slaked lime from quicklime. That is, quicklime is calcium oxide solid. By reacting it with water, we will get calcium hydroxide. That is slakelime. This is also an exothermic reaction. There's one more that we use in our day-to-day life. Combustion of substances. That is also an exothermic reaction. Combustion. Combustion of fuels, combustion of paper, anything. Wherever we burn something, there is heat evolved. So that is also an exothermic reaction. So these are all chemical changes or chemical reactions that are exothermic. Just to go through the examples again, magnesium reacting with hydrochloric acid. So commonly metals reacting with acid, they usually evolve heat. Then sodium hydroxide, that is a base, the solid base dissolving in water to give the alkaline solution. That is also an exothermic reaction. Then diluting concentrated acids to get the dilute acid. That is exothermic. Then we have the other reactions. Sodium metal reacting with water, giving rise to sodium hydroxide and evolving hydrogen gas. These are reactions that you have already discussed in your previous lessons. Then acid-base neutralization reaction, production of slakelime from quicklime. That is calcium oxide solid is quicklime. Adding water to it, you can prepare or produce calcium hydroxide, that is slakelime. That is again an exothermic reaction. And combustion. We will be discussing some of these reactions again as well, but just as examples, you all have to remember these are all exothermic reactions. So with that understanding, now we will move on to a topic where we discuss how we can represent these exothermic reactions. For that, we use the energy level diagrams. So an exothermic reaction can be illustrated by an energy level diagram. This is something you all have to remember, students, an energy level diagram. So first, I will use the example that we did as a common reaction. If we take the reaction, we have the reactants becoming the products and evolving heat. We discussed the example where we used magnesium solid reacting with hydrochloric acid aqueous, giving rise to magnesium chloride aqueous and evolving H2 gas. So that is the reaction. So for these, we can use energy level diagrams to represent these reactions. It can be exothermic or the second type endothermic. For both, we can use energy level diagrams. This is how we draw the energy level diagrams. For that, we need to have an axis for energy, and then we need to denote the different energy levels for the reactants as well as the products. So this is the energy axis, and then we have to show the reactants and products. In these types of reactions, reactants have higher energy than products. I have told you all that before. So then we have to represent them here. So this is the energy level that has higher energy. So the reactants will be here. And products have less energy or lower energy compared to reactants. So the products will be here. And when this change takes place, there will be release of energy. So that is denoted like this. You use an arrow to show that the reaction is taking place from reactant to products, and at the same time, there is energy is released. Or in other words, we can also say heat is evolved. Everything means the same. Energy is actually released in the form of heat energy. So, energy is released during this reaction. Is this okay, student? So, we have the reactants with higher energy, products with lesser energy. When the reaction takes place, energy is released. That is an exothermic reaction. So, for this reaction, if we use the example, that also can be denoted or illustrated using the energy level diagram. If we do that, again we need to draw another energy level diagram. So, here we have the energy axis, and then we need to have the energy levels, and we need to label this as energy, and we need to show the reactants and products here. What are the reactants? We had magnesium solid and hydrochloric acid aqueous. You have to show the reactants as well as their physical states. And the products, magnesium chloride aqueous and the liberation of H2 gas. So, during this reaction, the change occurs like this, where energy is released. So, there is energy is released. So, is this okay, students? This is how we represent the example in an energy level diagram. Energy axis, the reactants are above, products are below. When the change takes place, energy is released. For a common reaction, we represent it this way. We write it as reactants and products, and again we show that energy is released. So, but for an example, we have to make sure we write the reactants and products with the correct physical states. Is that okay? So, that is the first type of reaction that is accompanied by the increase in temperature. Why? Because the reactants liberate or evolve energy in the form of heat, and that is taken up by the reaction mixture, that is the solution as well as the beaker. So, because of that, the solution and the beaker become hot, and such reactions are known as exothermic. So, we have the second type, endothermic reactions. So, to understand endothermic reactions, again we will do an activity. Explore further about the heat changes occurring in a chemical reaction. So, to understand that, again we need beakers, and here we will be using citric acid and sodium bicarbonate. Now, citric acid and sodium bicarbonate, they come as solids. So, if you have the solutions already, you can use them. Otherwise, we will need to take the citric acid and sodium bicarbonate solids individually, and you have to dissolve them separately, and then we need to mix the two solutions together and observe the change in temperature. So, we will go through the steps again. The method: add about 10 cm cube of the citric acid solution to a small beaker and record its temperature. So, initially you are going to mix the citric acid in water, 10 cm cube of water, and take the initial temperature. So, here we need to take T1. Record the temperature of the sodium bicarbonate solution also. So, this is T2, but those two are the initial temperatures. And here remember students, when you take the temperature reading, if they are equal, then no problem. We take it as the initial temperature. If the temperatures are different, what we do is we take the average of the two initial temperatures. Add about 10 centimeter cube of the sodium bicarbonate solution to the beaker containing citric acid. Stir and note the temperature. So this is going to be the final temperature when both the citric acid and sodium bicarbonate react together. State your observation. So here we have to say whether the temperature increases or the temperature decreases during the reaction. So again, it's a very simple activity, students. We need to prepare the two solutions, mix them together, stir well and record the temperature, that is the initial temperature as well as the final temperature once the citric acid reacts with sodium bicarbonate. So let's do the activity in the lab. So students, now we are going to observe the heat change that takes place when citric acid reacts with sodium bicarbonate. So here you can see this is citric acid and here I have sodium bicarbonate. So now I am going to prepare the two solutions separately and take the temperature reading of the solutions individually. To do that, I need about 10 centimeter cubes of the solution. So 10 centimeter cube of water into both the beakers. So here first I will dissolve citric acid. So here you can see actually when citric acid dissolves also, you can see a change in temperature. So if we take the initial temperature of citric acid, you can see students, the temperature of citric acid is 23 degrees Celsius. Similarly, I will have to dissolve sodium bicarbonate in this. And then we need to take the temperature reading. So now I will take the temperature reading of sodium bicarbonate. You all can see students, the temperature of sodium bicarbonate is 28 degrees Celsius. So when the temperatures of the two solutions are different, we need to take an average of the two temperature values. So we had 23 degrees Celsius and 28 degrees Celsius. So we will take an average of the two as the initial temperature. Then I will add the citric acid to sodium bicarbonate, and once the reaction takes place, we will need to read the thermometer reading. So here I am going to mix. Now you will be able to observe the thermometer reading. I will mix the two solutions together. To make sure that the heat gets distributed uniformly, we need to mix the reaction mixture. Now can you all see the temperature? Now can you all see students? The temperature has dropped to 23 degrees Celsius. So in this reaction, you can observe clearly that there is a drop in temperature. So we had two solutions. We had to take the temperature reading of the solutions individually, and when those are different, we need to take the average of the temperature, and after that, once the solutions are mixed together, you were able to observe clearly that there was a drop in temperature or decrease in temperature. So from that, you all can understand the second type of heat change associated with chemical reactions, that is endothermic reactions. Okay, students. So, you all were able to observe the heat changes. You can remember the temperatures that we recorded. What were they? Initially, citric acid, it was 23 degrees Celsius in temperature. And sodium bicarbonate, that was 28 degrees Celsius in temperature. So, what is the initial temperature? I told you all students, we need to take the average. So, 23 plus 28 divided by 2, then that would be 25.5 degrees Celsius. That's the initial temperature. Then what did we get? After mixing citric acid with sodium bicarbonate, the temperature became 23 degrees Celsius. So, what was the change? Temperature decreased. Temperature decreased. So, why does the temperature decrease? I am sure you already know the answer, because heat is absorbed by the reactants. So, here in some reactions, the temperature decreases due to absorption of heat. And what do we call these reactions as? These reactions are known as endothermic reactions. So, when the reactants absorb heat and react to form the products, there is decrease in temperature, and such reactions are known as endothermic reactions. So, those are the second types of reactions based on heat change that accompanies chemical reaction. With that, I will move on to the endothermic reactions. So, students, you all can remember the activity when sodium bicarbonate reacted with citric acid. What was the observation? You saw that the temperature decreased. The reason is that reactants, that is sodium bicarbonate and citric acid, they absorb heat and form the products. So, that type of reaction is known as endothermic reaction. The chemical reactions happening with the absorption of heat are called endothermic reactions. Endo means in. So, they are absorbing heat. Endothermic reactions can be represented simply as follows. So, as a common reaction, if we take the reactants becoming the product, so as I told you, the reactants absorb heat and they form the products. So, as I discussed with you all before, if we consider the reaction mixture. Now, we have this is the reaction mixture. In this, we have the reactant 1 and reactant 2, let's say sodium bicarbonate and citric acid. What they do is they absorb energy. From where? So the reactants absorb heat, or you can say energy, from the beaker and the medium, or you can say solution. So therefore what happens? Therefore the temperature of the beaker and the solution decreases. So that is what happens here. Because the reactants absorb heat from the solution as well as the beaker. When you touch the beaker, you can feel it becoming cool, and you saw that the temperature decreases because the heat was absorbed, and they form the products. So what do you think of the heat content of the reactants and products? Reactant absorb heat and form the products. So that means products will have more energy than the reactants. So here, if we denote that in this, energy in reactants is less than that of products. Or in other words, products have more energy than reactants. That is why they absorb heat. Is this clear to you all, students? So we will again look at the reaction. So in this, the reactants absorb heat, form the products, and they absorb the heat from the mixture as well as the beaker. So therefore, there is a decrease in temperature. And that means the energy that is present in the reactants is less than the energy that is present in products. Is that clear to you all? So now we will look at some examples. So one example, we have already discussed the reaction between citric acid and sodium bicarbonate. So that is an endothermic reaction. Another reaction that we discussed with the first activity. What was that? Ammonium chloride dissolving in water. So most of the ammonium salts dissolving in water. Is an endothermic reaction. So as examples, we can take ammonium chloride, NH4Cl, ammonium sulfate, NH4 twice SO4, even urea. Urea is a fertilizer. You all know the chemical formula, CONH2 twice. So all these, when they dissolve in water, they absorb heat. So it's an endothermic reaction. Then there is one more reaction that you are familiar with, the thermal decomposition. Can you all remember an example? The limestone, calcium carbonate, when you provide high amount of heat, it decomposes and forms quicklime and releases carbon dioxide gas. So that is the thermal decomposition reaction. For those, we need to supply heat. So they are all endothermic reactions. So thermal decomposition reactions. thermal decomposition reaction. So, example, calcium carbonate solid. When you heat, you can remember we use this delta symbol to indicate we provide heat, or instead of that, we can also write heat, either the delta symbol or heat. One of it has to be indicated. It will give us calcium oxide solid and carbon dioxide gas. One example of thermal decomposition. I am sure you can remember many other examples. So, these are a few examples of endothermic reactions. Citric acid and sodium bicarbonate reacting, then ammonium salts dissolving in water, and also thermal decomposition reaction. So, those are examples. And that is the second type of reaction where reactants absorb heat energy and form the product. Therefore, the container as well as the solution become cooler. So, the temperature decreases. And as you already know, we can illustrate these reactions using the energy level diagram. And that is what I am going to do next. Use an energy level diagram for the endothermic reaction. So, an endothermic reaction can be illustrated by an energy level diagram. Like in the previous instance, students, here also we will use a common reaction to denote the endothermic reaction. So, to do that, we need to draw the energy level diagram. So, here this is energy, this particular axis, and then we need to use lines to denote the reactants and products. So, what are where do we put the reactants? Here, reactants absorb heat and go to a higher energy level. So, reactant will be here and the products will be here. So, when this change takes place, you can see there is absorption of heat. Energy is absorbed. So, this is how an endothermic reaction takes place. Reactants have less energy, products have more energy. So, the vessel becomes cold. Is it clear to you all students now? So, up to here, we have discussed that the chemical reactions take place or occur with the change in heat energy or change in temperature. The reason being, if heat is absorbed by the reactants, then the container becomes cool and that is known as an endothermic reaction. If the heat is released by the reactants, the container becomes warm, there is increase in temperature and that is known as exothermic reaction. So far we measured the temperature to make sure or to observe clearly that there is a change in temperature, whether the temperature increased or decreased. But we did not do any calculations related to this temperature change. So next what we are going to discuss is how to calculate the heat change related to chemical reactions. So for that also we will be doing an activity.